All right, working with the ambiguous case. So the ambiguous case is basically an oblique triangle in which the sign law is used, but because of the information in the question, two possible triangles can be created. So stemming off from our investigation in class and swinging that string back and forth, what we want to determine is we want to determine whether from this information this is going to create no triangle at all, one triangle, or two triangles, right? Determine the number of solutions that exist for X, Y, and Z. So every time I tackle a question like this, I'm going to draw my triangle in the exact same direction so there is very less confusion. So I'm always going to draw my angle starting like this, where my angle that I'm given is in this far left corner. I know this angle is 30 degrees. Okay? And then my angle Y is going to occur over here with the side length here. Okay? And then it says X is 24 meters. So X could be either potentially a triangle here, or it could actually be a triangle here. So this is what could potentially occur. So in order for that to occur, we want to compare this side length X with Y and the height of the triangle. Okay? So in order to compare it to the height, we have to figure out what the height of the triangle is. So making a note back to here from our investigation, to find the height of the triangle, we always take B, which is the oddball length, times sine of the angle that you're given. So the height of this triangle, I'm going to take 42, and I'm going to multiply it by the sine of 30. And so what I get is a height of 21 meters. So in order for this to be an ambiguous case, which means two solutions, this length X would have to be larger than the height, but smaller than the other length. So 24 has to be larger than the height, but smaller than Y. And in this case it is. X is 24, my height was 21, and my length is 42. So this is the ambiguous case, which means I'm going to get two solutions. Two solutions means I'm literally drawing two different triangles. Okay? So let's solve for this first triangle. This first triangle is, we always want to solve for this guy. Okay? So very straightforward. All this is solving using law. So I have an angle with its opposite side. So sine of 30. So this is case 1 that I'm solving. Sine of 30 equals over 24 is equal to sine of Y over 42. So my angle Y is equal to 61 degrees. Okay, let's put it up top here. Now I'm going to find angle Z. Well, angle Z, pretty straightforward, would be I'd subtract these two angles from 180. 180 minus 30 minus 61. So angle Z would equal 89 degrees. So this angle up here would be 89. So that's my second angle. And now I'm going to find this third side, Z. So when I find the third side Z, I'm going to set up the same ratio, sine of 30 over 24 equals sine of 89 is my angle Z over Z. So I'm going to cross multiply and divide, and I get a Z value of 48 meters. Okay, so these would be the answers to case 1. These are the answers to this triangle that I just created. Okay, but now I have to consider my second case. Case 2. And while case 2, we're talking about this triangle, X, Y, Z. And so obviously this angle is going to be completely different than this angle. But if I set this same ratio up, because technically this would be 24, I'm always the calculator will always spit out this 61 degrees. So that's why it's ambiguous, because your calculator can't actually calculate this angle here. Okay, but what we do know is once I swing this side this way, this creates an isosceles triangle here. And this was 61 degrees. That means this is going to be 61 degrees. So that means angle Y is going to be 180 minus 61. So in case 2, the Y angle in the second case is always 180 minus your original. So angle Y works out to be 119 degrees. So now that we know this angle is 119, now we're going to solve everything else like we normally would. So that's our answer. Angle Z would be 180 minus 119 minus 30, just like we did over here, which works out to be 31 degrees. And then finally we're going to use this angle and this side, Z, to find our last ratio. So I'm going to take sine of 30 over 24 equals sine of 31 over Z. And our length for our second triangle ends up to be 24.7 meters. Okay, and that is the ambiguous case.